Hello and welcome to this PLAXIS Elite training. My name is Marina Trevisoli and I'll be guiding you through this session. So today we're going to learn about the 3D geometry basic concepts available in PLAXIS 3D Elite. The agenda of our training is subdivided into the following topics. Let's first take a look on the CAD Drawing Space, some concepts in terms of geometry definitions, as well as the importing options available in the software, the 3D geometry tools, and the concepts related to the geometry paradigm. So the CAD drawing space is central to the entry of a new numerical model in the software. So all editings that can be applied to the numerical model can be done using the graphical drawing commands in the drawing space. So if we take a look here on the bottom, some functionalities related to the adjustments of the drawing space in terms of enabling the grid, snapping tools, ortho, and so on that can be helpful on creating new geometries. And on the top, we have the main commands related to the entry of geometry and how we can better visualize the information included in the model. If you'd like to understand in details each of the commands and how they are applied to the drawing space, you can take a look on the user's manual available in the software by accessing the help menu here. So let's zoom in on the top portion of our PLAXIS LE interface. So here is basically where the main actions will happen in the software. On the top, we can see the schema to develop the whole model from a left to right fashion so we can fully create the geometry, apply materials, pore pressures, and so on until solving the analysis. But there are other functionalities as well in the 3D space. So here, these tools are important for the visualization of the model. So we can see the model not only in 3D, which is the default view, but also switch the 2D plan view, XZ and YZ if you like to see the model as a session. Also, we can zoom in or zoom out the model, and especially on this portion is how we can select things on the drawing space. So I can select based on points, as we see here, based on the lines, depending on the action that we are looking for, find how the selection will look like. Finally, the model is built by the use of regions, surface, and consequently the transfer to layers. We'll take a look on it. But here basically you can select the surfaces and regions and see all of them included in the model. Having this initial understanding of the CAD drawing space, let's focus today on the geometry menu. So the geometry menu can be accessed on the top of the software, as I mentioned before. And this is the menu that provides options to adjust the display of the model geometry. So all dialogues controlling the properties of model geometry may be found under this menu. This is the menu we're going to use to create the geometry, import the geometry, and also use some additional tools to adjust geometry if needed. In terms of the geometry objects definition in 3D, we need to have a clear understanding of the following concepts. 3D models are created through a combination of regions and surfaces in PLAXIS LE. If you like to create a 3D model in PLAXIS LE, you need to have a combination of the use of regions and surfaces in the software. So what is a region? So a region does not contain any elevation data in terms of Z elevation, but they are simply 2D extrusions which cut through all surfaces in a cookie-cutter type fashion. We can see a region defined here in this image surrounding the surface. So you can imagine that the region is used to limit the model extension in PLAXIS LE. Surfaces in a numerical model are typically defined at the intersection of the geostrata. So we can use surfaces, as we can see here, for the division between existing topography and man-made structures or between subsurface layers of our model. A surface in PLAXIS 3D LE can be formed either based on a mesh, a grid, or a constant value. So the surface would be a constant elevation. So we have these three possibilities of representing a surface in PLAXIS 3D LE. And what are the minimum conditions for building the 3D model in PLAXIS LE? We need at least one layer in the model. So to have one layer in the model, we need at least two surfaces for composing this one layer. So one surface for the top and one for the bottom, and at least one region for limiting the model extension as well. So these are requirements that we need to keep in mind when handling PLAXIS LE. So let's say you only have the topography of the top of your model. You can import this topography and define a bottom surface using a constant elevation, if it's the case, or even define a certain offset of your top elevation to consider as a bottom. So in PLAXIS LE, we can handle the 3D model creation in three different ways. The first one is what we call a layer cake approach. So what is a layer cake? Is the main approach for a 3D model, and which means that between two surfaces we have a layer. So it's just the use of regions and surfaces in PLAXIS LE. So one of the examples on creating the 3D model with regions and surfaces is as follows. So we can switch to the plan view and draw the region for our model. As you can see here, we have two regions interconnected that were defined in the plane view. There's no elevation set for them. We can then import the bottom surface, and in this case is a grid. As you can see, we define the bottom surface, and we define the second surface, which is in a higher order compared to the first one. And you can see here that the region starts to adjust to this new layer included in the model. The third surface is the top surface here that we included, and we can see that the region will keep up with the extension of the surfaces in the model. As a final result for this case, what we would expect is a model that even including surfaces that are extended more than the region itself, the final model will be limited by the region. And also, as we have two regions, we may define a certain material for this portion and a certain material for this other portion here, respecting the vertical sidewalls. The second option for model creation is the combination of a layer cake model and a material volume mesh. So in that sense, we need the regions, surfaces, and volume meshes in the model. The third option is the block model. So in this case, we can define the regions, a top surface for the model, and the block model as well. All geometries are entered within the context of the current world coordinate system and the model system. This is something users can adjust. And the geometry can be entered in PLAXIS LE in a number of different ways. Let's list them here. So first of all, the geometry can be, we can cut and paste the geometry data coordinate from an external software. We can manually type the coordinates if you'd like. We can, as a third option, import the geometry from external sources, so DXF, shapefiles, and so on. The fourth option is transferring the 3D model from PLAXIS Designer, as these two tools are interconnected, or you can extrude the 2D model from PLAXIS 2D LE. When accessing the geometry menu, the first two options user will see refer to the Regions and Region Properties dialog. When clicking on the Regions dialog, users will see the regions that are already included in the model, also referring to the order of each of these regions. Besides that, here is the dialog that users can create new regions, delete existing ones, and also access the properties of a region. Note that by selecting New from Surfaces, you can convert a surface into a region, respecting the limits of the surface as the representation of the XY coordinates of the region. When we take a look on the Properties button, we can access the information for each of the regions. A region is basically a polygon, and here we can see the coordinates x and y related to the region. At this portion, if we like to include the coordinates of a region or manually type, this can be done here in this dialog. It's important to point out that the third feature available under the geometry menu is actually the draw region polygon. So besides including the coordinates and evaluating the region properties, we can also draw the region directly in the drawing space. When we reach the features related to surfaces and surface properties, here is where we can actually access the information of the surfaces included in the model. So the surfaces dialog, similar to the region, lists all the surfaces in the model, in the same sense the order of these surfaces in the model, but also what is the definition option of the surface. If you remember, we can have three types of surfaces: meshes, grids, and constant values. Here, the user can also create new surfaces, delete, or access the property of the selected surface. When we are handling surfaces as meshes, here we can see the coordinates of the node points referring to the surface. We can also delete the meshes or paste the mesh data from external sources. If in the case of having surfaces as grids, we can also see the information of the coordinate points of each of the points in the grid. Additionally, have some functionalities related to create the grid, import the data grid, import scatter data, to then convert to a grid, and so on. For the grid option, there are advanced capabilities in terms of handling the interpolation, adjusting the surface, and defining the grid lines. When talking about importing external sources, we can find the import feature available under the geometry menu to import different types of data file. So if we take a look on this dialog, we'll notice that there are several different types of importing options here. Note that most of these importing options refer to the import of region data import. If you'd like to import grids or meshes, then we'll need to access directly the surface properties referring to this entity. So we can have the import of region data from DXF, shapefile, Microsoft Excel, and let's say you have a PLAXIS LE model in another type of module. For example, you have a model setting consolidation and you like to make the same evaluation for this model in the slope stability. You can then import from existing models or results files as well. Another option for importing is the import of cross-section data if you'd like to use the cross-sections to represent and convert these cross-sections into a 3D representation of your site. Material volume meshes, bedding guides, and block models are three types of geometry paradigm that can be imported in this dialog as well. They refer to advanced model creation. The surface geometry as a grid can be imported from external sources. When we access the surface property and define here the definition option as grid, we'll have these two options here for importing data grid and import scatter data. In the case of proceeding with import scatter data, users can bring a point cloud to compose the grid creation. This source data is interpolated into the surface at the series of regular or irregular grid lines as defined by the user, using a process known as kriging. PLAXIS LE implements ordinary kriging and the point kriging method to estimate the value at every grid line junction. If we take a look on the import from file options, you'll notice that there are different types of file formats that can be used to bring the scatter data referred to the grid. If we're talking about surfaces as meshes, these can be imported as well. So in this case, we can have, for example, an Excel file with a point cloud, and we can paste the mesh data directly into PLAXIS LE. In the case of having the surface developed in PLAXIS Designer, you can simply use your keyboard and press Ctrl C and then Ctrl V directly in the Surface Properties dialog. There are 3D tools available in the software to help users handle geometry. The first one is related to the tools options here. So you can see that there is actually the snap all, offset, slice region, automatic region intersection. These functionalities are pretty much the same as PLAXIS 2D LE, just extended to the 3D and focus on the region geometry. Users can understand each of them by accessing the user manual or watching the PLAXIS 2D LE training as well. For the 3D tools, we have these 4 functionalities to help users handle the geometry. The 3D tools are mainly focused on fixing model surfaces. The first feature available for the 3D tools refers to adjust overlaps. Here in this image, we can have a clear understanding of how this functionality works in the software. So this option allows you to adjust surface elevations for overlapping surface areas. So we can see here on the top that other surface can be compared to the currently selected surface. Either one of the two surfaces can be adjusted, with the other remaining fixed. We can also restrict this correction to a certain region in the model as well. The second one refers to the cut surface. So the cut surface function allows the user to cut a three-dimensional surface with a plane using some of the polygonization methods available. Then, a new region on the resulting intersection points between the plane and the surface will be generated. There have been implemented different assumptions to cutting the surface through planes in PLAXIS LE. This operation can respect one of the methods available in the software. Users can then generate a new surface or export the coordinates point of intersection as a text file. The third functionality refers to Find Regions tool. The user can create a region at the interface between two surfaces. So in this case, the action can be restricted to the entire model or just a portion, and user needs to select two surfaces, the top and bottom, along with the polygonization method. In that sense, software will generate a new region referring to this intersection, and then it's also possible to make adjustments or export as text file. The fourth option is referring to check for pinchouts. So 3D models using surface need to avoid the existence of pinchouts in negative volumes. These pinchouts can lead to numerical instability in the analysis. The action referring to check for pinchouts will evaluate for negative values that are created by intersecting surfaces. Negative volumes are created when a surface crosses through and above another surface that is higher in the volume surface list. Consequently, the software will list the coordinate points and the unit difference referring to each of these pinchouts. Depending on the quantity criticity of the pinchouts, the software recommends to adjust them using the functionalities available in PLAXIS Designer. One of the differentiators of PLAXIS LE is the capacity of handling the 3D model creation in several different ways. We can see here in this list that we can use a simple approach converting 2D sessions to complex ones as handling block models, material volume meshes, and even profile spline blending. The different geometry creations are consistent with current 3D modeling practices and developed in a way that it's easy to use. For the 2D extrusions, any PLAXIS 2D LE model can be saved as a 3D model. The lines then will be intelligently converted to surface grids in 3D. In the same way, the anchors will be converted to the 3D anchors, respecting the out-of-plane spacing defined in 2D. For cross-sections, any number of parallel 2D profile cross-sections can be stitched together. This methodology is useful for complex tailings bioanalysis and open pit excavations. There is a new workflow available in PLAXIS Designer. Users can import several 2D cross-sections, and these cross-sections will have a unique geolocation. The software then applies the interpretation skeleton to refine the connection lines and generate the 3D model interpolated. This 3D model can then be imported into PLAXIS LE. For a layer cake, let's just point out that any number of surfaces can be stacked to form layers. Layers do not need to cover the entire model extents, and complex surface intersection tools are available in PLAXIS LE to help users handle a layer cake approach. For a layered cake plus material volume meshes, the layer cake surfaces separate boundaries of material layers vertically, forming a set of stacking layers. Some type of geological models are really complex to be designed using the layer cake approach. In this sense, the material volume mesh was implemented to overcome the limitations of the traditional approach. A material volume mesh is defined by a mesh that specifies the boundary shape of a volume, create distinct objects for irregular volumes like dikes, ore bodies, and so on. The material volume meshes are prioritized in the 3D slope stability analysis. Here we can see a practical example of a dam core. There is a transition between the inclined core and the central core. In that sense, it must be modeled as an MVM. We can see the internal structure of the core defined as a module volume. The block model data can be imported to form the basis for stability calculation. Each of the blocks will have a lithology assigned, and regional materials can be assigned based on the blocks. These blocks can be imported under the geometry menu, and users can bring from CSV files or even PLAXIS Designer. Here are some remarks referring to our session. PLAXIS 3D LE considers as preliminary condition a layer cake approach, but can support a variety of model creation options as volume meshes, block models, bedding guides, and others. The users have the flexibility of interconnecting the 3D model with PLAXIS Designer. Different geometry creation paradigms are available in PLAXIS Designer to provide the most comprehensive experience to users. Surfaces can be fixed for overlapping issues using the 3D tools in the software, and it's recommended to avoid pinch outs and negative volumes in the model, as these can lead to numerical instability. As you notice, PLAXIS 3D LE is completely scalable to support from simple to complex and extensive 3D slope stability models. Thank you for your attention.